So we are in our analytical instrumentation lab where we have a diverse range of instruments. This is an ultra-performance liquid chromatograph that is coupled to a photodiode array detector and a single quad mass spectrometer. And essentially we're doing chromatography and detecting the components as they come out. So everybody in their life has done chromatography. When we take a piece of paper, put ink on it, let's say black ink, and then it gets wet, you see the colors spread across the paper. And how they spread is dependent on whether they like the paper or whether they like the liquid. And so if they like the liquid, they go further. If they like the paper, they don't move as much. We're doing the exact same thing, only instead of paper, we're using this chromatographic column. So it's packed with modified sand, very, very tiny, 1.7 micron. And so in here is the surface, the paper, and then we're pumping the water or the different solvents through to carry them and do the separation. And so at the bottom we have our pump, we have our sample manager where we would put a vial, a needle comes down and injects it, and then it goes onto the column. So this is where the magic happens, the separation. As the analytes come off the column, they're going to travel down into the detector. Now this detector, unlike anything else that we have in the lab, is able to collect what we call full spectral data. And so that means we can see every single wavelength of UV vis light and how much of that ultraviolet visible light is being absorbed by the molecule. That allows us to get a fingerprint that we can use for comparison, and it also allows us to quantitate. After the analytes move from here, the molecules, they go down into the single quad detector. And mass spectrometry allows us to look at things based upon their mass to charge ratio. And so that's looking at a molecule's actual weight, so the individual molecule, not the total weight of the material, versus its charge ratio. And this is very characteristic. This allows us to look at UV vis absorbance. But some molecules, like polymers, don't absorb UV vis light. And so this allows us to actually see the other compounds, and we call it orthogonal or different detection. So it allows us to really fully characterize the compounds that we're looking at. More and more mass spectrometry is becoming a standard in the industry. So if we look at environmental, food, pharmaceutical, a lot of those industries are moving to mass spectrometry because it can get down to lower and lower numbers and due to tighter and tighter regulatory requirements. Previously, we didn't have the ability to use these two pieces of equipment. So now the fact that we can get full spectral data, get down to lower sensitivities, and give students experience with mass spectrometry really prepares them to go out and understand that their skills are transferable to a wide variety of different areas. We have the students run effluent samples, we have them run finished products, raw materials, and so they really get a wide gambit of experiences on this instrument. Many organizations only let the students prepare samples and hand it off to a technician. We have the ability through this lab and through this instrument of giving students the hands-on experience. Now they're actually running it, seeing what it feels like, and using state-of-the-art software that they can manipulate the data, so at the end they get a chromatogram that they can look at, understand and interpret, and understand how they got there.